Hello, today we're going to go through the maths practice test. This is my second time recording it, so quite a bit tired. If you're expecting somebody to be firing on all cylinders, well, that's probably not going to be the case. So this might be a very long video, who knows. So I hope you'll forgive me. This is the second time and I'm quite tired and I'm got to get to work shortly. So I'll go through as many as I can. I may not solve the entire thing depending on how much time I have left today, because I do want to have this information out there as soon as possible to all of you. Okay, so we're looking at the practice exam and it's divided into two sections. So section A, they should be much more of the basic type problems, very familiar, so simple familiar and possibly, rarely, but less frequently you'll find complex familiar. These are the questions that are typically already presented to you in number format, so you won't have to convert text or you won't have to convert a paragraph, for example, into a mathematical form before you can solve it. Often it's just, add these fractions together and away you go. So section A, the instructions are that you don't typically get marks for any of your working. However, if you make a mistake, let's say you've used 2 steps to solve the question. If you've made a mistake, then perhaps you might get partial marks if you have some working shown. So it's up to you. But you should be answering these ones pretty quickly. That's the ideal case for part A. Let's get started into question 1. Question 1 of section A. Write 24/30ths in simplest form. To simplify fractions, we just have to divide by the highest common factor to both. So we look at the numerator and all of its possible divisors, which are called factors, and we look at the number 30 on the bottom to see all of its factors and try and find if there's a similarity between the two, and if there are some, we want to pick the biggest one possible. So 24 can be divided by 1, 2, 3, 4, 6, 8, and so on. The bottom one, the 30, can be divided by 1, 2, 3, 5, 6. In fact, 6 is pretty good. So 6 was common so far. 6, 10, and obviously 30. So I think the highest common factor is 6. So let's divide them both by 6. So 24 divided by 6 should give me 4. 30 divided by 6 should give me 5. And we're done. Going on to question 2. Convert 31/10ths into a mixed number. Okay, so we've got an improper fraction where the numerator is bigger than the denominator. And we're basically, a mixed number is a mixture between fraction and whole numbers format. So we want to have some number in front of something tenths. And to do that, we want to find out how many groups of the numerator are currently stored in the top. So we have 3 groups of 10 plus 1 is up, that makes 31. So our answer is going to be 3 1/10. Another way of doing this is to do a little short division. So 10, 31, see how many times you can fit that in there. And before you go to decimals, you're actually just going to leave it as a remainder. So remainder of 1, and that remainder 1 goes and stays there in the numerator. That's how you can solve these ones. Moving on, question 3. Write down 4 to the power of 2 times 7 to the power of 3 in expanded form. Expanded form means that you are going to sort of stretch out what these symbols mean. So when we're dealing with powers, sometimes called an index or an indice, or sometimes called an exponent or an order, when you're dealing with these, it just means that the base number, in this case here 4, has been multiplied against itself this many times. Likewise, this base number has been multiplied against itself this many times. So let's put that into action here. So expanding it out, 4 has been multiplied against itself this many times. So it's 4 times 4. And we carry this one down, so multiplied. 7 is the base number now, and it's multiplied against itself this many times. And we're done. Going on to question 4. Determine the reciprocal of 17/4. Okay, reciprocal means upside down fraction. So all I got to do is flip it over upside down, and that's the answer. So 4/17. It's literally that easy. The only thing that's tricky is remembering what the word reciprocal means. Question 5. List the first 5 multiples of 12. Okay, this one we're dealing with multiples. A multiple is a whole number multiplier against the original number. So we're looking for basically the 12 times, well, we're looking for the 12 times tables, and we want to pick the first 5. So 1 times 12, 2 times 12, 3 times 12, 4 times 12, and of course 5 times 12. Okay. The only mistake that I typically find in these ones is that some kids will do the opposite. Well, they might write factors, or another common mistake is that the students will forget that 1 times is the first one of the list. So and you got to be careful. It does say ask for the first set, not just any multiple of 12. Scrolling on, we got some steam here. Question 6, simple familiar. So again, these ones should be very straightforward to solve. They're already presented in number format, so you don't have to do any text to mathematics conversions. Here, 18 take away -3. Okay, well, these two will combine to make a plus sign, so that's actually 18 plus 3. And I'm going to lay down my equal signs to show that this line is equivalent in answer to the next row down below. That's how it's communicated. 18 plus 3 is 21. Yes. B, -45 divided by -5. Negative divided by negative is a positive, so I can literally scrub these away and just look at the numbers now. 45 divided by 5, that looks like 9. That looks like the 5 times tables, which is an answer of 9. Moving on to C, -17 plus 4. So if you recall that addition and subtraction, you can actually shuffle the order, provided that you carry the negative signs correctly. So the idea is that, 1 plus 2 is the same answer as 2 plus 1. What's happened here is I've just swapped them around. If I have -1, then I must maintain that, so it'll be -1 over here. So we're going to use that trick to just make more sense of this problem. I'm just going to flip it backwards. 4 plus -17, which is basically 4 take away 17. Now I can just figure this out. My answer is going to go dropping into the negatives, so I'm just going to put negative sign down first. Now all I've got to worry about is the difference between these two numbers. 17 remove 4 will give me the answer, because I've already decided that whatever the answer is, it's going to be negative. So 17 take away 4, I should get an answer of 13. Sorry, I'm just going to itchy nose right now, so my eyes are watering. Okay. D, 2 elevenths plus 5 elevenths. Okay, this one's easy. To add fractions together, you must make sure that the denominators are identical, otherwise you can't do it. In this occasion here, it is already identical, so all we have to worry about is adding the numerators together. So 2 plus 5 gives me 7, therefore the answer is 7 elevenths. All right, moving on. Question 7. Compare the following by placing a less than, a greater than, or equal to symbol in the boxes to make the statements true. Okay, so we just got to figure out which one's bigger, or perhaps maybe in some occasions they might be the same. So 3 versus -5. Well, a positive number is always bigger than a negative number, so the mouth always faces towards the bigger number. Right, next one. B, 1/11th versus 1/5. Well, a fraction is actually a division problem. So this actually means 1 divided by 11. So you can imagine, having $1 in your pocket and you have to share it amongst 11 friends evenly. Compare this to having $1 and you must share it amongst 5 of your friends evenly. You can see that this one here, each person's going to get a bigger piece compared to this. So we know that 1/5 is going to be bigger. And a short way of doing this is just if the numerator is identical, so if these numbers are identical, then the one with a bigger denominator is basically a bigger divisor. You're dividing by a bigger amount. Therefore, the end result's going to be much, much more small. So that's another way of just knowing the answer straight away. C, 4 to the power of 3 compared to 12. Okay, so I'm going to convert this number here into a regular whole number that we can now compare easily. So what does 4 to the power of 3 mean? Well, it means that 4 is multiplied by itself this many times. So, okay, so that's 4/3. And now we can just calculate that out. 4 times 4 is 16. And then times that by 4, 16, 32, 64. So this number here is actually 64. And we can see clearly that is much bigger than 12. So we're going to put the mouth facing that way. Here we got 23 versus 46 over 2. Now we got a fraction compared to a whole number. So what can we do? We can turn this into a fraction as well, and then maybe we need to make the denominators the same. So I could multiply this up, and therefore I could see which one is the bigger one. Another approach here that I think makes more sense is to simplify this one, because I can see that I can divide both of them by 2, which would make this whole denominator piece disappear. So let's try that. So 2 divided by 2 gives me 1. So I'm going to cross out the old one and put a 1 in its place. 46 divided by 2 is actually 23. Cross out the old one and put 23 in its place. So we're basically looking at 23 over 1, which is just 23. Because remember, this means 23 divided by 1, which means it's just going to be 23. We can see that both sides of this box are equal, so we're going to put the equal sign there. Moving on. Determine the LCM of 8 and 10. Okay. Let's see. This means lowest common multiple. Okay. Multiple is going to be many times bigger than the original. So basically the multiplication times tables. So out of all the multiplication times tables of 8 and all the multiplication times tables of 10, we want to find any ones that are common to both lists. And if there's multiple choices, we want to pick the lowest choice, the lowest number. That makes sense. So of the times tables, I know that for 8 times tables, you got 8, 16, and 24, and 32, and you keep going. For 10 times tables, you got 10, 20, 30, 40, 50, and so on. And in fact, the number that appears to common to both is the number 40. You would also likely have 80 as well, would be common to both times tables. However, 40 is the lowest one on the list, so that is the lowest common multiple. We're moving on. Question 9. Order the following integers. Integers means a whole number that can be negative or positive. In descending order. To descend means to go down, all right? So you would descend down the stairs. That means we're starting for the highest number and working our way down to the lowest number. So a high value number down to a low value number. Let's use that. So we've got to find in our list here which one's the biggest. Start from there. So 13 is the biggest, so we can start our list from there. I'm going to cross it out as I go. Some students will forget that they've left some behind, or they might have reused the same number multiple times. So it's always good practice to just cross them out as you start to use them. So the next biggest, so we got the biggest one, we want to go to the next biggest one that's possible, which is 4. So we're going to cross that one out. And then we're going to keep going down the list. There's no 3, there's no 2, there's no 1, there's no 0, there's no -1, but there is a -2, so that's the next thing on our list. So we can cross that one away. And we just finished our list here. I think you understand the process. All right, that's the end of section A. It's pretty quick. I am trying to make for time because I do need to get to work. I'm going to have a crack at some of the questions for section B in a minute. I may not get through them all. We'll see. All right, we're doing section B now. And section B is going to take quite a bit more of your time. It does require you to show all of your working. So there's right on the screen right now, you can see that it has a little bit of text. Some mistakes that students in the past have made is that they skip over it without reading it. It's always good to just read over it and check what the instructions are. So it says that it says that working is required. So you can't just go 5. That's not going to give you full marks. It's also asking you to use Kiwa setting out wherever possible. Kiwa is an acronym that some of the teachers use. It's just a way of presenting the solution in a very clearly communicated format. So I will show you what that looks like in some of the examples further down the road. And hopefully when you see it in action, you'll understand what Kiwa looks like. It also asks you to express your fractions in simplest form. So it's always good advice to leave your answer in simplest form whenever you have doubts. Go, should I simplify? Yes, you should, every single time where you can. Write your responses in the space. You don't have to fill the entire space. If you need more space, they always build in extra blank paper towards the back of the exam. So if you're midway through a question and you need more room, just put a symbol and say on the back, page 12, and then the teacher can go and flip to the back and see the rest of your answer there. So as long as you have some way of communicating to your teacher on the page itself where the rest of your solution is. All right, we're going to crack on with the first bit of section B. All right, section B, question 1. Determine the HCF of these two numbers and show all working. So HCF, what does that mean? Highest common factor. Now, a factor is a divisor of the original number. You can think of it, and there will be numbers smaller or equal to the original. Okay, so you can always imagine they're fewer in a way than the original's value. So we're looking for any common numbers that can divide both of them, and if there's multiple choices that are common to both, we want to pick the highest one possible. So we basically need to find all of our factors, all of our divisors. To do this, if you looked at my YouTube channel, there's a video about highest common factor as well as lowest common multiple. I think I call them HCF and LCM on the video title. I show that you can use a method of a factor tree. So I can divide that by 2. And then I can divide that by 2. And then I can divide that by 3. Okay, and so on. And then you're basically going to look for all of these to try and find all the possible factors. However, I do note that in the video that you will need to make multiple of these with a different starting number, for example, and you use that to try and find the full list. I did notice that on the given solutions, which is on Firefly, that there's another method of finding it, and it's called the list method. And I kind of like it. It's a bit of work, especially for me, because I can't do problem solving. I can't do the basic, multiplying, dividing things so quickly. I'm sure many of you are much faster, much more capable students than I am. So you will forgive me if I go a bit slowly here. So the method is that for these two numbers, we're going to look for all the factors. So I'm just going to have a list here for 120 and a list here for 72. Okay. And I might just make it a bit of a table here to simplify things. So in this region here, I'm going to divide that further into 2 rows. Likewise here. And just like with the factor tree, so 120, I could break that into 2 times 60. Okay, these two here would go here. See? And likewise, 1 times 120 will also work because 1 is also a factor and also 120 is also a factor. So this is what we're going to go with. And we're going to keep going this way until these 2 rows pretty much converge, meaning that they pretty much meet up near to the same number. You'll see what I mean. Let's go ahead and do them, and forgive me if I get stuck. We can divide that by 3, so 3 times 40. We can divide that by 4, which gives me 30. Divide that by 6, which is 20. Yes. 6, 7, no, can I do it by 8? I think 8 will work. Let's see, 8 fits into 120, fits in there once, 4 remainder, so we could do 15. Can we do 9? Don't know if I can do 9. Can we do 10? So 10 and 12. Now that can you see that the 10 and 12 are pretty much, we've reached the end of all the lists. We've got all the factors of 120, so I can stop there. We're going to do the list for 72. I might change the color here just so you can see that they are separate. So 72. 1 times 72. I can do 2 times 36. I can do, let's see, is it divisible by 3? Yes, it is. 3 fits into 72, fits in there twice with 1 remaining. 3 is in there 4 times, so 24. Can I do it by 4? Let's try that. 72 fits in there once with 3 remainders, 32, so that fits in there 8 times. 18. Can't do 5. Let's try 6. Let's see if I can divide that by 6. I believe I can. Let's see, 6 goes into 72, fits in there once, 1 remaining, therefore 12. Can I do 7? Probably not. Don't recognize it from the 7 times tables. 8, it can go in there 9 times. And now we're pretty much converging on that end of the list. I'm pretty confident we have all of them. Let's just look in both of our lists to find the biggest, find the common ones. We have, I believe these are all in common. We also have 8. So it appears that our highest common factor, it appears to be 8. Just going to check the solutions. I've got a feeling I've made a mistake somewhere. I've missed one. Oh, I missed 5. I've missed 5 in this list here. Sorry, everybody. I skipped over 5. Clearly, this ends with a 0, so it should be divisible by 5. So 5 times 24 gives me 120, so that's also a possibility. And 24 also shows up in both lists. So 24 is clearly the highest common number to both. Therefore, the highest common factor of these two input numbers, the highest common factor is 24. All right, we're going to go to the next one. Question 2. In a room, 3/8 of the people are boys, 1/4 are girls, and the rest are adults. So it's going to be basically 3 fractions we're dealing with here. Determine the fraction of people in the room that are adults. Remember to use keyword problem solving, setting out. Okay. Let's just try and understand the question bit first and where we're going, and then we'll worry about what keyword looks like. I did allude to it earlier when we sort of introduced section B. When you deal with these questions that has proportion of a group of people, one clue that I can give to you is that everyone is 1 if we're dealing with fractions. So the people would be a value of 1. Okay, so 3/8 of 1 are boys, 1/4 of 1 are girls, and therefore the remaining part of that 1 number, the remainder would be the adults. That's how this works out. That's just a clue. Every time you see a problem dealing with a certain proportion, a fraction of these people, a fraction of these people, and the rest. Okay, if you need to refer to everyone as a group, it should be everyone. That's your clue. So keyword. K stands for keywords, E stands for expression or equation, W stands for working out, and A is to present your answer as a sentence. So keywords, the K step. I will color them out, so let's do green. Okay. The keywords is the key thing you're trying to find. So what are you trying to find? You're trying to find the fraction of people in the room that are adults. So let's say fraction of adults. That's the K step. Okay, now we're going to go into the E step of keyword. Okay, E stands for expression. So expression is show the problem as a number in number format. And we are really looking for you to demonstrate the skill of assembling it all together as one. Okay, when students don't know how to solve something, they'll often do it little piece by little piece. And then somewhere at the very end of their story, they then try and smack it together. That doesn't show quite the same amount of skill as somebody who can assemble the problem as one thing. So try to do this from now on. It is a little bit harder. However, if you can do this now, you will find later down the road, especially for year 7 maths, you'll find later down the road, your life will be you'll be stronger. You'll be able to tackle the more difficult things, especially when we get to things like algebra, which we'll do later this year. So the fraction of adults is basically going to be 3/8 take away from everyone, as well as take away the 1/4. So out of everyone, we are subtracting the boys, which are 3/8 of them. And we're also subtracting the girls, which is 1/4 of them. Now I've got the equation step. That's the expression step. So I've written it all together as one. I haven't separated into smaller pieces. I haven't done them as isolated, scattered calculations across the page. That's not what I've done here. Now I'm going to go to W, which stands for working out. So now we're going to solve this one. So I'm going to turn that into a fraction so I can work on this. Now I need to make sure the bottoms, the denominators, are the same to make this possible. So to do that, I need to scale this one up to, let's scale up to 8, because 8's the lowest common multiple I can use for all of these, lowest common multiple of these 3 numbers. times that by 2. So that's going to be 8 on 8, take away 3/8, take away 2/8. 8 take 3 is 5. And then copy down this down to here. And 5 take 2 is 3/8. So I've done my working. So this is the W step. And this bit here is the E step. And this bit here is the K step. And now we are up to, what color should I use? Orange? I'll use orange. A for Kiwa is present your answer as a statement. Write it in English. Don't just, you're not actually quite done yet. This is kind of meaningless unless you've presented it in English form. So you have to write, so the A step here is 3/8 of the people are adults. Okay, so that is the Kiwa format. I'm not going to go over what Kiwa means again. I'm just going to assume you know it, and that allows me to free up my time to get through as many questions of Part B as I can before I run out and have to go to work. Question 3. Lily parked her car 3 levels below ground, caught the lift, went up 8 floors to the coffee shop, then went down 2 floors to her office. On what floor was her office? Remember to use Kiwa problem solving setting out. Okay, so there's a couple things we can do here. We can actually use a diagram to solve this one. The diagram would be good to just give you a visual to confirm if your mathematics is fine. So for example, if I've got ground floor, and then I'm just going to have 1, 2, 3, 4 upstairs, 1, 2, 3 downstairs. So we're 3 levels below, so we're on -3. We went up 8 floors, so 1, 2, 3, 4, 5, 6, 7, 8. So we're up 8 floors. And then we went down 2 floors, so 1, 2 floors. So what floor are we on now? So 1, 2, we're on the 3rd floor. So we know the answer is 3. Do you get the full marks for writing that as your answer? If that's the only thing the teacher sees on the page, we can't give you full marks because, as section B, the very start said, you must show all working out. This is not sufficient, okay? It is a tool, but it's not sufficient. Specifically, since they're asking you to show the Kiwa format, which requires showing things as an expression. Because this one here is worth 2 marks, and the way this works out for us, at least, is that every tick is worth half a point. So therefore, we are looking to see where we would have 4 tick marks associated with this problem. How many tick marks do you think we have shown? Probably 1, maybe 2. Therefore, we're leaving a lot of it left on the table. We haven't done a good job. So let's do this the proper way. We know the answer is 3. Let's just try and show it using Kiwa format. I'm going to assume you've seen my previous example, so you know exactly what Kiwa format looks like. I'm not going to go over that again. So keywords. So Lily floor is equal to, so she started 3 levels below. So we're going up and down. We can show up and down by using positive and negative signs on the numbers. So this is going to be -3 to show that's below ground. And then we're going to have up 8 floors. So we're just going to add that 8 there. So that's how we're going to work this out. We're going to start left to right and follow the sentence as it is. So we start off -3 floors. Then we add 8 floors up. So that's a +8. And then, so and is a plus sign. And is a plus sign. This is a +8. And this is down 2 floors. So we're going down 2 floors. And that's the end of the information we're given. So that's the expression. Let's solve the rest now here. So -3 plus 8 should be 5. And that should be 3. And then we show, therefore, Lily's office is on 3rd floor. Okay, so we get points for your Kiwa set out here. We may usually, not always, you don't get a point for having the keywords, but it's good communication. Often we probably give you more points for the working out stage there. So perhaps a tick for the expression, and a tick for the work, 2 ticks for the working, or possibly more if it's a longer problem, and then a tick for the final answer written in English. All right, we're ready to go into question 4 next. Question 4. Place the following fractions in ascending order. To ascend means to go upwards. So we must be starting from the lowest value or lowest number and work our way to the highest value or highest number, biggest number. So how do we work this out? So there's 2 approaches. I think in a previous live stream sometime last year, what I ended up trying to do is I tried to convert all of these to the same number. I try to convert all the denominators to be the same number to try and solve it. I then later realized that I don't have to do that. There's a simpler method. The method I mentioned will work, but it's a lot of work, especially when you're trying to find a common factor between 8 and 33. That's going to be tough. It's going to be something really, really big, and therefore it's going to get ugly very fast. So the simpler method is to identify that we actually have identical numerators. So the only thing that's different are the denominators. And we know from earlier on, if you remember in section A, I think towards the end of the video, if the denominator is larger, the divisor is larger. Therefore, you're dividing into smaller and smaller pieces. So if we have a really large denominator, with everything else being the same, we should have a smaller result. So the smallest number here by far is going to be this one, because $3 divided amongst 33 people is going to be a tiny fraction of dollars left to everybody. So that's going to be our first one. Ascending means starting from small to largest. So we're going to go upwards. That's what it means. So this is our smallest number. And I'm going to put a comma down. I'm going to cross it out as I go along. The next number, that's going to be 3 over 8. Cross that away. 3 over 7. Cross that one away. 3 over 3. Cross that away. 3 over 2. So this one here is going to be our biggest number. This one here is going to be our smallest number. Now, when it comes to marking these questions here, this one here is worth 1 mark, so we're looking for 2 ticks somewhere. And if you have this sequence backwards, then you obviously lose one of those tick marks. And perhaps if you have maybe the correct sequence, but 2 of them are back to front, then you might lose one of those tick marks, perhaps, depending on your teacher. Question 5. Use order of operations to solve. Show all steps and answer in simplest form. In fact, one thing I suggest to students, especially if some students, maybe about 20%, maybe 30% of the students, they tend to forget some parts of questions. And let's say they'll see the question really quickly and then they'll start solving it. And then later realize when they get the marks back that they haven't actually responded to the question correctly because they misunderstood something or they did not read it all. If you're that type of person, and even if you're not that type of person, I highly suggest that you use a highlighter. So I'm highlighting the information here. So I know I have to use order of operations, which to me means BOMDAS. Now this acronym here is different from teacher to teacher. Some people call it BID maths or BOD maths or something like that. They're all the same idea. So I'm just knowing that that's what that means for my kids and my group. Showing all steps means working. And simplest form means simplify any fraction we've got if we have any fractions as our answer. Let's go in. I'm going to go through these pretty quickly. So we know that double negatives makes a positive, especially if they're side by side in an addition subtraction problem. So it's going to be 4 plus 8 take away 12. So that's going to be 12 take 12, which is going to be 0. Moving on. Here, let's see, I can switch this out, so that makes a negative, because positive, negative, side by side, rock, paper, scissors, negative wins. So we've got 7 and 4. And I copy out the rest as it was. So I've just done a little quick conversion to make it simpler for myself. I run the BOMDAS protocol. Okay, brackets is the first thing I do, so I must solve this bit first. 3 take away 5, the answer is negative 2. Okay, that's what's left remaining in that bracket. I'll copy the rest of the working. Now I run the BOMDAS brackets. Well, I do have brackets, but there's nothing left to do inside. So I move on. Order, there's no powers or things like that in there. Multiplication, yes I do. So I must do this bit next. So I've got to do this bit here. Okay, so negative 4 times negative 2. A negative times a negative actually makes a positive. So it's going to be a positive answer. So 4 and 2 times together makes 8. So the answer is positive 8. So 7 plus 8. And if I can do addition properly in my head, I think that's 15. Yes. Moving on. Here we go. 15 plus 6 squared divided by 2. So bombed as particle. Brackets, there are none. Order, we do actually. So it's here. So I must do this bit first. So 6 squared means 6 times 6. That's what it means. Because it's multiplied, this number's been multiplied against itself this many times, if you recall from earlier in the videos. I copy the rest of it out. 6 times 6 is 36. Copy the rest. Now, bombed as particle. Brackets, there are none. Order, there are none. Multiplication, there is none. Division, yes we do, so we must do this bit first. So positive 36 divided by positive 2. It's going to be a positive answer. So basically halving that, so it's going to be, 30 divided by 2 is 15, plus 3 is 18. 15 plus 18, so that's going to give me, 3 in the end, 2, 33 I believe. Let me check my answer there. I'm going a bit quickly. Yes, 33. Moving on. This one here is going to be a bit more tricky. Most kids would struggle, especially in term 1, if you haven't been doing a lot of practice problems. Here we go. Bombed as particle. Obviously, we've got brackets here. So we've got 2 sets of brackets. So we must do something in these brackets. Okay, and then we got to see how we've located we start in here or starting in here. Both will be fine. We have to run the bombed as particle again. So if there's multiple things in here, there's currently only 2 things in here. If there's more than 2 things in there, then you have to run through the list again. Bombed as, what happens first within that bracket. So we don't have to worry about that so much. I've got a mixed number adding on to another mixed number. Now I've got 2 approaches. One, I can just simply add the mixed numbers as they are. I will have to convert these to be the same number for it to work out. However, something else I noticed is that I could turn these both into improper fractions by absorbing the whole number in front and storing it up in the numerator. Which way am I going to go forward? I am going to choose to turn them both into an improper fraction first, because I know that once I've added these together, I will have some fraction that I will need to divide with some fraction. So it'll be easier for me if I just have improper fractions here. That's what I'm thinking. You'll see what I mean when we get down the road. Okay, let's do this one here. To absorb the whole number, 2 whole pizzas that have been sliced into 3s. That's 2 groups of 3, so 2 times 3, which is 6. Add that to the top that's already got some stuff in there, so that makes 7. Okay, let's do this one here. 1 group of 5 is 5, plus the 2 that's already sitting there. That makes 7 as well. I'm just double checking in my head, that's what I'm doing. Over here, I'm just going to leave it. Now my next row of working is to convert them to be the same denominator. I don't have to make all 4 of them the same. I just need to make the ones that are doing adding, subtracting the same. So I need to make those the same. So I'm looking for the lowest common multiple of both of those that can work. So of the 3 times tables and the 5 times tables, what's common to both and what's the lowest number possible? So in that case there, 15 is the lowest number possible. So let's scale this by timesing them both by 5. This one here I'm scaling by 3 to turn them into the respective common fractions. So 7 times 5 is 35. 7 times 3 is 21. And likewise for here, I need to make them both the same. The lowest common multiple in this occasion here is 10. So all I need to do is just double this one. So it's going to be 4 on top, 10 on bottom. Now that the denominators are all the same, all I have to do is just worry about the numerators. So 35 plus 21. So that's going to give me 56 on 15. Now there's nothing left. I still have my brackets, but they can just go away now because I've isolated down to a single number. Divided by 4/10 take away 1/10. This is going to leave us 3/10 remaining. And the brackets again, they fall away. Do I need to convert them to be the same base? No, I don't actually. When you do multiplying or dividing of fractions, you do not have to convert their base, the denominators to be the same. If you do, you often make the problem harder for yourself. So I just remember you don't have to. To divide fractions, I need to convert this into the reciprocal format. So if I flip this one upside down, I'm then allowed to change the divide symbol into a multiplication symbol. So let's do that. So what we will have is 56 on 15 multiplied by 10 on 3. Now I can just multiply the tops together and multiply the bottoms together. However, I will know that it's going to be a really, really big number on the top. So let's see, 56 times 10 is going to be 560. Oh, God. 15 times 3 is going to be 15, 30, 45. And I have to simplify my answer. Remember at the very top we highlighted there? Simplest form. I think most of us, including myself, would find simplifying this one a little bit tricky. So I would rather, before I just multiply them across, I'm actually going to simplify first. Can I simplify vertically? Can I simplify 56 and 15? Do they have common factors? 1, yes. 2, no. 3, 5 and 6, no. 4, no. 5, no. Okay, so it looks like they don't have anything in common, so I can't simplify vertically. What about this one here? Can I divide them by anything that's common? Not really, so there's nothing possible there. However, if you recall the trick, you can actually simplify diagonally only in the case of multiplication. Only when you multiply are you allowed to do diagonals to simplify. 15 and 10, you can absolutely simplify those. So I can divide them both by 5. So 15 divided by 5 gives me 3. So I cross out the old one, put a 3 in its place. 10 can be divided by 5, cross it out, and give me the answer of 2 and put that in its place. So what we're really dealing with is 56 times by 2 now, which is a lot easier to work with. 56 times by 2, so 5 times 2 is 10, 112. 3 times 3 for the denominator is going to give me 9, and we're done. That is question 5 done. I am getting very low on time, so I may not be able to solve many more, so we'll see how many I can get to. All right, section B, question 6. The minimum temperature at a ski resort is given in the following table. Some days of the week and different temperatures of the day. Calculate the largest difference. Difference means subtract. So that's a maths word that has a mathematical symbol going with it. It means to subtract of temperature between 2 consecutive days. Now, they've already told you what consecutive means. It means 2 neighboring days, or 2 side by side, or 2 one after another, or 2 in series. These are different ways of saying the same thing. So that means we have to find the difference between Monday and Tuesday and see what that answer is. Difference between Tuesday and Wednesday, find the difference between those two, and so on. So we just got to find the largest difference between them all and then show our working out. How many points is this question worth? It's worth 3. So we're looking for 6 tick marks. So you can't just say the answer is Friday, Saturday. If you only did that, you might get 1 tick, maybe 2, if you're lucky. So you're not going to collect all of your marks by just writing the answer by doing it all in your head. You can't do that. In maths, we want to know, can you solve it? But also, can you communicate that you are correct? Can you communicate a proof? So those two go hand in hand. You can't just go, the answer is 5. You can't do that in the real world because people are going to go, I don't believe you. Show me the proof. Oh, I know it. I just did it in my head. You've got to show how you get your answers, even on these really basic ones. So how are we going to show working out? I think we basically have to do a calculation between every 2 days together. So let's do Monday and Tuesday. So I could do Tuesday, remove Monday. I could do that as well if I wanted to, but I think it'll still be the same result every time anyway. So Monday is -1 degree Celsius, and then we're going to take away Tuesday, which is 3 degrees Celsius there. So we're going to get more negatives, so it's going to be -4. Let's do Tuesday to Wednesday. So Tuesday was 3 degrees, and Wednesday was -3, so take away -3. Remember, it's a difference. So we got difference. That means subtract. That's what's happening here between all of them. That's the common thing here. 3 take away negative. It's going to be 3 plus 3. So that's going to be 6. Wednesday, Thursday is going to be -3 take away -6. So that's going to be, so again, that's that difference there. -3 take away negative number, so it's basically -3 plus 6 is going to be +3. Let's do Thursday and Friday. Thursday was -6. Friday is -3. Take away -3. That's going to be -6 plus 3. So that's going to be -3. Now we're doing Friday, Saturday. Friday was -3. Saturday was 4 degrees. So we're dealing with, let's see. -3 take away 4 is getting more negative. It's going to be -7. Okay, so we're looking here, the largest difference. When you're looking for the word difference means just how different they are. Okay, we're not necessarily interested in direction necessarily. So for example, if I have 2 students and I'm trying to find the difference in their height. Okay, so here's one student and here's the other student, and I want to find the difference in their height. I could take, let's say this is student A and this is student B. I can find that difference in height, which is this region here. I can find that difference by doing B take away A, or I could do A take away B. What I will find is that one of them will give me a negative answer. So B take away A, that will give me a positive answer, because a big number take away a small number will give you a positive answer. If I do A take away B, so a small number take away a larger number, I'm actually going to get a negative answer. But either way around, I'm going to have a value of difference. It'll be the same thing. So let's say the person here of A, their height is, let's say this person A is 2, and then let's say this person B is 3. Let's do the maths here. So if I do B take A, that's going to be 3 take 2, which is going to give me 1. If I do A take B, it's going to be 2 take away 3. I'm going to get a negative answer. It's going to be -1. Can you see that in both occasions here, we still have a value of, oh, that didn't show up very well, did it? We both have a value of 1. It's just the sign has changed depending on which way around we did the process. So when we're trying to compare all of these, we're actually just interested in the number, not necessarily the sign, because they've mentioned the word difference. So which is the largest number, forgetting the plus or minus in our end calculation. So we got a 4, a 6, a 3, a 3, and a 7. So clearly the largest difference occurred between Friday and Saturday. Are we done? Well, we probably have to answer as a sentence, so we're going to do that. I'll do this in pink. Largest difference consecutive days was between Friday, Saturday. Okay, so that's how I'd answer the question. I think I have to leave it there. I do have to get these videos collected, edited, and uploaded, and I do need to get to the office to do some science experiments on video. So I apologize I haven't got through any further than this. If you want to know how to solve the rest, I highly suggest that you have a look at the marking scheme on Firefly. So if you go to the Term 1 page for Year 7 Mathematics on Firefly, you will find the document that we printed earlier, and also underneath that you'll have the marking scheme, which you can read and compare and to see how you solve them out. I will catch you everybody at school hopefully later this week.